Friends, today we learn about ideal and non-ideal solution. Ideal and non-ideal solution. Yes, let's move on. Ideal and non-ideal solution. Generally, binary liquid solutions can be classified into ideal and non-ideal solution on the basis of Raoult's law. Binary liquid solutions. Binary liquid solutions. Binary liquid solutions are classified into binary liquid solutions can classified into ideal and non-ideal solution. See, ideal and non-ideal solution. Ideal solutions and a non-ideal solution. Non-ideal solution. Basis of Raoult's law. Basis of Raoult's law. Yes. In this session, we have to finish ideal and non-ideal solution. And again, non-ideal solution classified into two types. They are solutions shows positive deviation and a solution showing negative deviation. The non-ideal solution can classified into two types. Solution shows positive deviation and negative deviation. Yes. In this session we have to finish these terms. Okay, right. Let's move on. What is mean by ideal solution? What is mean by ideal solution? Let's move on. What is mean by ideal solution? Ideal solution. Solution which obeys Raoult's law over the entire range of concentration are known as ideal solution. Solution which obeys Raoult's law over the entire range of concentration. Over the entire range of concentration are called as ideal solution. Ideal solution. What does mean ideal solution? The solution which obeys the Raoult's law, that solution is an ideal solution. See, first of all, what are the characteristics of the ideal solution? Let's move on. What are the characteristics of the ideal solution? Let's see. Then the ideal solution must be like forces must be similar to unlike forces. The solution force must be, see, the solution force must be similar to unlike forces. This means two components A and B. A and B is the two components to be ideal solution. A and B, two components, is said to be ideal solution if AB molecular interaction, see, AB molecular interaction is similar to AA interaction and BB interaction. AA interaction and BB interaction. If two components A is said to be ideal solution, so AB interaction or intermolecular forces equal to AA interaction and BB interaction forces. See, let's see second character of ideal solution. See, there is no volume change. There is no volume change if mixing of two liquids. If two liquids are mixing, if the two liquids are mixing, there is no volume change. That means volume of mixing of the two components must be 0. It is delta V mix equal to 0. Delta V volume change mixture equal to 0. That means if two solutions are mixing, there is no changing volume. So no change in volume. No change in volume. No change in volume. Yes. Next, if two solutions are mixing, enthalpy changes equal to 0. Enthalpy changes equal to means delta H mix equal to 0. Enthalpy changes, no change in enthalpy. No change in enthalpy. What does mean? What does mean? Enthalpy change means there is no heat observed, there is no heat released during the mixing of two components. There is no heat change mixing of two components. Yes. Next point is, if total pressure of the solution, see, total pressure of the solution equal to partial pressure of the component A and component B. See, the total pressure of solution equal to sum of partial pressure of the component PA plus PB. Let's the graph plotted between, say, look at the graph plotted between vapor pressure versus mole fraction. The graph plotted between vapor pressure versus mole fraction. Look at, see, chi1 equal to 1 in this point, chi1 equal to, see, in this chi1 equal to, see, chi1 equal to 1. Yes, it's P1 means PA, it is PB, PA is the vapor pressure of the pure component A, and P0 is the vapor pressure of the pure component B. See, it is PA, it is PB, it is the PA and it is the PB. Look at the total pressure of solution equal to PA plus PB. Yes, PA plus PB. Look at the graph. This is the ideal solution graph. It is the ideal solution. See, ideal solution. See, in this ideal solution, delta V mix equal to 0 means there is no changing in volume. There is no volume decreasing or increasing. So delta H means enthalpy change equal to 0. What does mean? There is no heat changes. Heat not released, not observed. The total pressure of the solution equal to sum of the partial pressure of the component A and component B for the pure components. Yes, AB interaction equal to AA interaction and BB interaction. See, a perfect ideal solution is rare, but many solutions behaves ideally, particularly in dilute solution. Yes, a perfect ideal solution is rare, but many solutions behaves ideally, particularly in dilute solution. See, what are the example of ideal solution? Look at the examples. N-hexane and N-heptane. Bromoethane, chloroethane. See, bromoethane and chloroethane. Benzene and toluene, and chlorobenzene and bromobenzene. See, chlorobenzene and bromobenzene, chlorobenzene and bromobenzene. These are the ideal solution. N-hexane, N-heptane. See, N-hexane, N-heptane and bromoethane, chloroethane, benzene, toluene, chlorobenzene, bromobenzene. These are example of ideal solution. These are example of ideal solution. So this is about ideal solution. Let's move on. What is the meaning of non-ideal solution? What is the meaning of non-ideal solution? Let's move on. Non-ideal solution. See. Non-ideal solution. What does mean non-ideal solution? The solution which does not obey Raoult's law over the entire range of concentration are called non-ideal solution. Yes. For the solution which does not obeys Raoult's law over the entire range of concentration are called non-ideal solution. Non-ideal solutions. Yes. For non-ideal solution, what are the characteristics of the non-ideal solution? Very simple. See, if the volume change delta H mix not equal to 0, yes, so the enthalpy change is not equal to 0. Next, the volume change is not equal to 0. Yes. Next, the PA pure component of solution is not equal to P naught A chi A, and PB is not equal to P naught B and chi B. Yes. Non-ideal solutions like forces are not similar to unlike forces. See, non-ideal solutions are like forces are not similar to unlike forces. What does mean? See, A and B. If the A and B is the non-ideal solution, AB interaction forces are not same for AA interaction and BB interaction. AA interaction and BB interaction. A interaction and BB interaction. Yes. Next. Non-ideal solutions are further classified into two types. The non-ideal solutions are further classified into two types. What are they? Solution showing positive deviation and solution showing negative deviation. Solution shows negative deviation. Let's move on. See, non-ideal solutions are classified into two types. What are they? Positive deviation and negative deviation. Solution shows positive deviations and solution shows the negative deviation. Let's move on. Solution shows positive deviation. Yes, solution shows positive deviation. Solution showing positive deviation. Yes. Very first point is the solution which does not obey Raoult's law. Yes, the solution which does not obey the Raoult's law. Yes. Solution which does not obeys Raoult's law. Yes. Next, in the second character is partial pressure of the solution is greater than pure solvent vapor pressure and chi. Yes. Next, partial pressure of the B is greater than P naught B into chi B. P naught B into chi B. Yes. What is the third character? Delta H mix. Delta H mix is greater than 0. Greater than 0, it means enthalpy change equal to positive. Enthalpy change equal to positive. Yes. Positive means heat absorbed the system. Heat absorbed the system. Yes. Next, fourth character is the delta V mix is greater than 0. It is equal to delta V equal to positive. 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 Yes. Next, in positive deviation, the intermolecular interaction between solute and solvent particles. Solute and solvent. See, solute and solvent. It is A is the solvent, B is the solute, is weaker than solute and solvent interaction. See, AB interactions are weaker than AA interaction and BB interaction. The molecules are A or B will escape more easily from the surface of solution than their pure state. Therefore, the vapor pressure of the solution will be higher. The vapor pressure of the solution is higher. Look at the graph. The graph plotted between vapor pressure versus mole fraction. In this, it is a. Look at this. Look at this. It is the P naught A. It is the P naught B. P naught B. It is the PA. It is the PB. Yes. Now, it is the ideal. This is the ideal solution graph. It is the ideal solution graph. Look at this ideal solution graph. See, AB interactions are weaker means the solution escape more easily from the surface of the solution in pure state. Therefore, the vapor pressure of the solution will be higher. Look at this. Higher than ideal solution graph. Yes, ideal solution graph. Yes. Next, what are the example of positive deviation? See, ethyl alcohol and acetone. Ethyl alcohol and acetone. Acetone and carbon disulfate. See, acetone and carbon disulfate. Carbon disulfide. Carbon tetrachloride and benzene. Carbon tetrachloride and benzene. Carbon tetrachloride and benzene. Yes. Next, acetone and benzene. acetone and benzene. Yes, ethyl alcohol and water. Ethyl alcohol and water. Ethyl alcohol and water. Ethyl alcohol and water. These are example of solution shows positive deviation. Solution shows positive deviation. Yes. Next is a solution shows negative deviation. Solution shows negative deviation. Let's move on. Solution shows negative deviation. Solution shows negative deviation. Solutions showing negative deviation. The very first point is the solution which does not obey Raoult's law. Which does not obey Raoult's law. Which does not obey Raoult's law. Yes. Now the point is PA is less than P naught A into chi A, and PB is less than P naught B into chi B. Yes, PA is the partial pressure of the solvent, pure solvent component, okay. Now the enthalpy change delta H mix is less than 0. That means it is equal to negative, delta H equal to negative, Yes. Next, volume changes is less than 0. That means it is also delta V equal to negative, Yes. Next, in case of negative deviation, the intermolecular forces of attraction AA and BB, AA and BB weaker than those of between AB interaction. Hence the molecule of A or B will escape more easily from their state. Therefore, vapor pressure of solution will be lower. The vapor solution will be lower. Yes. Next, look at the graph. So it is the PA, it is the PB. Yes. The dotted line represented the ideal solution vapor pressure. It is the ideal solution vapor pressure. Look at the downside graph. See, this is the lower vapor pressure of the non-ideal solution. It is a vapor pressure of the non-ideal solution, means negative deviation. This is the negative deviation. Look at this, negative deviation. See, look at the example of negative deviation. Nitric acid, HNO3 and water, and acetone and chloroform, and HCl and water, yes. Chloroform and benzene, Next, acetic acid and pyridine, So this is about ideal solution and non-ideal solution, and the types of non-ideal solution is positive deviation and negative deviation. So this is about ideal and non-ideal solution. Yes, thank you.